Okay, now I'm not sure. But I actually recorded my instruction here because it doesn't look like it's continuing a recording. So I'm going to go over this again. If it's redundant, I apologize. You've got these three equations. Straightforward system of three equations. And we're going to solve them. How are we going to solve them? Well, I gave you a suggestion. Eliminate y from these two equations because the 4 and the -2 match up nicely. Okay. And then and then you have to eliminate the same variable. And you do it from these two equations. And the y's match up nicely here. They match up much better than the z's or the x's. Okay. Now, a lot of times nothing matches up. You just got to go to big numbers. That can happen. Okay, so in order to do that, we multiply the second equation by 2 and keep the first equation the way it is, and we're going to get a 4y and a -4y. So we get equation 1 becomes still the same. And times the second equation becomes 12x minus 4y equals 10 or plus 10z equals -2. We add these, 12 and 2x and 12x is 14x. 4y and -4y is 0, so we're done there. 7z and 10z is 17z. -1 and -2 is -3. So I think everybody had this. Some people chose to multiply this equation by 2 and this equation by 4. Okay? Yeah, that works. You get slightly different equations here. And if you did that, you get different numbers here, but the equation you get here would be a multiple of this equation. Okay, well, then you do, I'm going to do eliminate from equations 3 and 2. So equation 3 is 5x plus 6y minus 8z equals 19. And then 3 times equation 2, because I'm going to multiply this by 3, and that'll match up the -6y with the 6y, and the y's will go away when we have. Okay, so we're going to have 15x. No, we're not. Multiplying equation 2 by 3, we're going to get 18x minus 6y plus 15z equals -3. Okay. Now we add these up, we get 23x. Right. Y's go away and we get plus 7z equals 16. Okay, now one caution. Let's say eliminate y. That doesn't mean just throw away the y's here, leaving you 2x plus 7z equals -1 and 12x plus 10z equals -2. About half the class did that. Okay, let's make sure we understand what we're doing and why we're doing it. This is equal to this. And this is equal to this. So 2 times this is equal to 2 times this. Multiply everything by 2. And then having doubled 2 things that are equal, we get 2 things that are equal. So this is equal to this, because that's the first equation. This is equal to this, because we've just doubled the quantities in the second equation. Okay? Now, if this is equal to this, and this is equal to this, then this plus this has to equal this plus this. Okay? So we add these equations. We add the x's, we add the y's, we add the z's, and we add the numbers over here. And we've chosen our multiples so that these go away. Now, you might have seen a place where somebody multiplies the second equation by -2, which will give you negative 12x plus 4y minus 10z equals 2. Okay? And then you'd have a 4y and a 4y, and you'd have to subtract one equation from the other. If you're subtracting one equation from the other, you're risking minus sign errors at every operation. So I recommend that you make the two quantities you're trying to eliminate equal and opposite. Okay? And then, of course, all the other quantities go along with that. So you maintain equality between one side and the other. Okay. In any case, you do all that, here's an equation. And this equation will be true anytime all three of these equations are true. Any value of x, y, and z, whatever value of x, y, and z solves this system of equations, has to solve this system. Or it has to solve this equation. Now, we have an equation in x and z. We need two equations in x and z, as you know from having solved the problems with two simultaneous equations. So to get another one, well, actually, we have two equations. We have this equation and we have this equation. So any solution of the system, again, instead of x, y, and z values satisfies the system, has to satisfy these two equations. So we solve the system. This equation. We have this equation. We solve this system of two equations. We write that as 14x minus 8z equals 19, and 23x plus 7z equals 16. I apparently started reading down here when I should have read up here. I'd like to blame it on the mask. It does improve my vision a little bit, but I think it's just I have my eyes closed or something. Okay, 14x plus 17z equals -3. Okay, I believe I've got them right now. Okay, so now we've got to eliminate one of these variables, and it's messy because all these, the 14 and the 23 are relatively prime, and the 17 and the 7 are relatively prime. Choosing the lesser of two evils, we multiply the first equation by 7, giving us 98x plus 119z equals -21. We multiply the second equation by -17 by negative and 17 times 20 is 340. 17 times 3 is 51. So I believe we get -291x minus 119z equals 21 times 17 is 340. And another 17, which is 357. And this doesn't work worth a darn. Now, what we're going to get from this should give us x equals 1. I'm not saying where I messed up any of the arithmetic, but obviously I did. So several of you got the right answer. I'm going to have to look at your work. Okay, it took me a minute. But when I came back and looked at this, I think I said it right. Negative 17 times 23 is 341 and 51, which is 391, of course. It's negative 391. I had 291. I don't know why I wrote it that way. I think I calculated it correctly. That's still not going to work. 119. Seventeen times 16 is not 357. Okay, 17 times 17 is 389, 289. So this should be 289 minus 17, which is 272. Is that what you said? Please don't talk over the recorders on them. But thanks. In any case. Okay. Oh, it's negative 272. Okay, that's going to work. Okay, now when we add this and this, we get negative 293 x equals negative 293. So x equals 1. Okay, so there we have a value of x. Now what do we do with that? We take our value of x and we plug it in one of these two equations, we get z. Now, at this point, of course, we just got two equations and two unknowns, and we assume that everybody can do that. If you can do the arithmetic like I can, okay? But everybody should know the procedure at this point, but let's do it. I'll plug this number back in here. This will give me equation 14 times 1 plus 17z equals 3. So that 14 plus 17z equals 3. Negative 3. So that 17z equals negative 17 and z equals negative 1. Which is exactly what I used when I did this, because I wanted to keep these numbers simple. Make sure it came out a good solution. Then finally, we take these numbers, x equals 1 and z equals negative 1. And we plug 1 in for x, and we plug in negative 1 for z, and we get the equation two times 1 plus 4 times y plus 7 times negative 1 equals negative 1. That gives us 4 here, negative 14 here. We get 4y minus 3 equals negative 1. That is a negative 1. It's a 4 minus 7, negative 3. And my arithmetic is failing me again because this gives me y equals 1/2, and I know that's not right. I know the 1 and the negative 1 are right. So what's wrong with this? Okay. Anybody spot my error? Hang on a minute. I don't know whether my eyes are crossed and my brain's been rewired, but 2 times 1 is 2, not 4. And 2 minus 7, negative 5. We get y equals 1. Now, while the recording was paused, I mentally plugged in x equals 1 equals negative 1 here, and then here. And in each case, I did get y equals 1. Okay. So I plug these 3 numbers in here. Everything is equal. Okay. Now, if everybody would check their masks again. Got a nasty variant out there. We don't want to be breathing each other's exhalations unless they've been mitigated a bit. If I haven't already said it, figure out which variable you want to eliminate, or figure out which variable you don't want to mess with, and then eliminate one of the others, because 2 of them are easy to eliminate. One of them is somewhat harder. Although you could eliminate any one of them, you get easier numbers if you make a good choice. Okay. Now, everybody either got a solution or they're well on track to getting a solution. I've seen any real errors. What I'm going to do, again, I'll label these 1, 2, 3. I'm going to choose to eliminate z, because I've just got 1s and 2s in front of z. So if I double this equation, I'll have a 2z and a negative 2z. The z will go away, right? Or if I multiply this equation by negative 2 and match it up with this one, again, I'll get a negative 2z and a 2z. Now, x will be fairly easy also because I've got a negative x here. If I double this equation, then the x's will go away. And if I triple this equation and add to this, the x's will go away, right? So it's kind of 6 of one, half dozen of another. So let's go ahead though and eliminate z, because 2 is an easier number than 3, although just a little bit easier. Okay. You could choose to eliminate y, but it would involve slightly bigger numbers. We'd have to multiply this by 2 and this by 3. That's 2 multiplications. Okay. I would multiply this one by 5 and this one by negative 2, right? And then y would be eliminated. That's totally feasible. There's nothing wrong with that. It's just less work to eliminate z or x. Okay, so eliminate z because that is in some sense the least work. Okay, so we do 1 plus 2 times the second equation. Oh, sorry, did everything at once. Take equation 1, 2x plus 3y minus 2z equals 2. And then 2 times equation 2 conveniently gives us negative 2x plus 4y plus bc equals 12. We add these, and conveniently, both X and Z go away. Excuse me. So we're going to immediately be able to solve for Y. Well, this gives us 7Y equals 14, so Y equals 2. So we're kind of left out. Since both Z and X got eliminated together, simplifies things a little bit. Okay, well, let's proceed. There are other things we could do. We could substitute Y equals 2 into these two equations now, which just give us numbers here, so we'd have two equations in X and Z. Now, if you understand that, that might be convenient, but I'm not going to take that shortcut at this point. We'll record you. Okay, so I'm going to do equation 2 multiplied by -2, which will match up to Z's, and give me 2x minus 4y minus 2z equals 6. And equation 3, which gives me 3x plus 5y plus 2z equals 19. Now, did I multiply by 6 by 2? No, I didn't. It's 12. Okay. That gives me the equation 5x plus y equals 31, which I know isn't right. So what's wrong here? 2 is this, -4y, -2z plus 2x.
-12.
Thank you. But let me pause this a second. Come on, button. Oh, come on. Okay. Well, I have a -12 here, not a 12. Thank you for pointing that out. I get 7. Okay, this is going to be much better. All right, so now I've got two equations. This equation is y equals 2, and this equation is 5x plus y equals 7. So now this for two equations is y equals 2. Five x plus y equals 7. Now at this stage, we don't have to do elimination. We just substitute y equals 2 here. And we immediately get x. We don't have to do anything magical here. And now we have values of x and y, which we can plug in to the first equation. I'm not going to do that step, I'm going to learn how to do that. That is going to give us z equals 3. That's what the majority of the thought. Okay. Okay, now I'm going to look at another system. I'll write it out, pausing the video. I've said something. It would work. Let's be sure. Say it right. We should eliminate y from 1 and 3, not 2 and 3. Okay. What? Say it again. Instead of from 2, 1 and 3, eliminate from 2 and 3. Okay, now you're not quite up to that. That's okay. You're going to find because everybody's done at least one of the eliminations in detail and correctly. So let's do equation 1, eliminate y because that's easy. All we have to do is double this equation to give us a -4 to go with this. So you get 2x plus 4y minus z 5, that's equation 1. We get 14x minus 4y plus 6z equals 16. We get 16x plus 5z equals 21. Okay. Now you can kind of spot that 16x and 5z, if z is x and z are both 1, that adds up, right? So you suspect that x and z are both 1. However, you don't know that. You don't know what's going to come out of the next system of equations. So just to be sure, go ahead and say, okay, let's see. Can eliminate y between these two equations. And we're going to have to do -3 times this added to this, because -3 times 4 gives us a -12 to match up with this 12. So we get 3 times equation 1, and we get equation 3. 3 times equation 1 is 6x plus 12y minus 3z equals 15. And equation 3 is 6x plus 12y I got stuck in the arithmetic too, the last track I was looking at, but there it is. They just copied down this equation. If I we should have multiplied the first equation by -3. Should give me a negative, a positive, and a negative. So that the -12y and the 12y add up to 0. -6x and 6x add up to 0. 3z and -3z add up to 0. -15 and 20 add up to 5. We get 0 equals 5. This is false. So to say that these 3 equations have a solution leads to a false statement. Okay. There is no solution because 0 can't equal 5. Now, just to understand a little better what's going on here, let's go back to a system of two equations. Well, let's just say so we have x plus 2y equals 12. Negative 2x minus 4y equals 8. I want 28. See why I'm that. Just like you graph. If I graph these two equations, I find that the y-intercept is x equals 6. So the y-intercept is 6, 0. I have to be careful where I label this. 6, 0. And the x-intercept, sorry, the y-intercept occurs when x equals, no. Okay, hang on. I want that to be there, and obviously 6 is there. Okay. If y equals 0, x is 12. So we've got the point 12, 0. On the first graph. If x equals 0, y is 6, so we have the point 0, 6. Okay, so the first equation so x plus 2y equals 12. Second equation, if y is 0, x is I want to make this negative 28. So things get too far apart. If y is 0, negative 2x equals negative 28, so x is 14. And the y-axis a little more, so you got the point 14, 0. If x equals 0, negative 4y equals negative 28, so y is negative 28 over negative 4, which is 7. The slope of this graph is rise divided by run, which is rise is negative 6, run is 12. The slope of this graph is negative 1/2. And from this point to this point, the rise is negative 7, the run is 14. So the slope is negative 1/2. This means that the lines are parallel and they never meet. Okay. So there's no solution. If we try to do elimination here, this is equation 1, this is equation 2. We do 2 times equation 1 and equation 2. That'll eliminate x because we'll have a 2x and a negative 2x. This gives us 2x plus 4y equals 24. And negative 2x minus 4y equals negative 28. If we add, we get 0 plus 0 equals negative 4, 0 equals negative 4. There's no solution. Lines are parallel and they never meet. The geometry of this situation is a little more complicated, it's in 3 dimensions. Each of these equations gives you a plane. It's a flat surface in 3 dimensions at some angle with whatever, okay? Since we get this, that means that these 2 planes, the left-hand side is just a multiple, left-hand side of this one is a multiple of left-hand side of this one, right? That means the planes are parallel, like 2 sheets of glass. But they don't meet because 0 equals 5. So they never meet. So there's no place where the 3 planes come together at a single point. Now, whether you understand that or not, it's worth thinking about. But that involves some 3-dimensional visualization. Not everybody's going to be good at doing that. So I'm not going to test you over that, but it's interesting to know and it's interesting to think about. And many of you can, or maybe all of you can visualize that. Okay. So there it is.